Hey everyone, and welcome back. We're doing a deep dive today into Oracle CPQ, specifically table-based configuration rules. You guys are here because you want to really understand these rules and how to use them. So we're working from the table-based configuration rules.pdf document. So if you want to follow along, grab a copy. This is going to be super helpful for anyone working with Oracle CPQ. Whether you're getting ready for a tech discussion or just curious about how these systems work, you're in the right place.
Yeah, these rules are really interesting because they offer this really streamlined way, kind of, dare I say, a user-friendly way to manage complex configuration logic within Oracle CPQ. So they kind of let you define actions based on external data tables without having to write any complicated BMQL code.
So it's almost like bringing external data directly into that configuration process to kind of help guide choices and make recommendations, or even set some boundaries.
Exactly. And that's a big deal because it offers a few advantages over traditional BMQL rules. Like,
Yeah,
for instance, they can return data from tables and attribute values, gives you more flexibility in how you use that data.
I'm intrigued. Can you give me a simple explanation of what these rules are in the context of Oracle CPQ?
Well, think of them as like a powerful mechanism within Oracle CPQ that let you define how your product configurations behave based on data stored in those external tables. So you're not just looking at the internal data, you're bringing in external information to really guide that whole configuration process.
So for our listeners that might not be as familiar, what are some of the advantages of using table-based configuration rules?
Well, they offer a few key benefits over those traditional BMQL rules. For example, they can return not just data from the tables, but also attribute values. And that gives you even more flexibility in how you use that data. Plus, there's a built-in query debugger, so troubleshooting is way easier. And maybe the best part is it's all point and click, so it's super approachable for users.
That user-friendliness sounds like a huge win, especially for folks who might not be BMQL experts. How do these rules actually play out for someone using this system?
Imagine you're configuring a product for a customer. As you're going through making selections, these table-based rules are checking conditions against data tables behind the scenes. So let's say the customer selects a specific product option, if that meets the rule's condition. The rule takes action, it can change something, recommend something, or even prevent an action from being taken. It's about keeping things consistent and in line with those defined rules.
Okay, so they're working behind the scenes, almost like a smart assistant, making sure things are consistent, and making suggestions based on real data.
Huh.
What would be the first step in setting one of these rules up?
It all starts in the Oracle CPQ interface. You'll navigate to the section where you manage your product configurations. There's a specific section for defining these rules, and you simply add a new one to get started.
Got it. So we're in the right section. What kind of information do we need to define for a new rule?
You'll give your rule a unique name and variable name. It's also really helpful to add a description so other people or even your future self can understand what the rule's purpose is. You can decide if the rule is active, inactive, or only active for users with full access.
So there's a lot of control over when a rule is applied. Could you also set specific dates for a rule to be in effect?
Absolutely. You can set specific start and end dates to control that time frame of the rule's activity. This is especially useful for rules related to promotions or seasonal product offerings.
I see how that would be really useful. You can even set up a rule for like a holiday promotion and not have to remember to turn it off later. What else is important to know about setting up these rules?
There's a really neat feature called AJX enabled. And when this is checked, the rule runs without having to refresh the page or requiring a specific action. It all happens seamlessly in the background.
So it's happening in the background without the user even knowing. That's a really cool feature. It seems like it would create a much more intuitive experience.
Exactly. And speaking of creating an intuitive experience, starting with Oracle CPQ 24b, there's this new attribute called the configuration context attribute that adds another layer of control to your rules.
A new attribute. Tell me more.
It's technically called configuration context, and it determines how the current configuration session got started. So it tells you if it's a brand new configuration, a reconfiguration, or if it's coming from a search flow.
So it knows how we got here, like a breadcrumb trail of sorts. What makes that useful in setting up our rule?
Well, you can use this attribute to make sure a rule only runs in specific situations. So maybe you only want a rule that applies when someone is creating a new configuration from scratch, or maybe only when they're modifying an existing asset. This attribute gives you that fine-grained control.
Okay, that makes sense. So we're adding more context to the rules. What's the next step in the setup process?
Next, you choose where you want the rule to apply, so you have a choice. Configuration, selection, which is really search flows, or both. Basically, you're deciding whether this rule will impact the configuration process itself, the search flow that users might use, or both.
So we're adding another layer of specificity. It sounds like flexibility is a key theme here.
You're catching on quickly. That brings us to the core of table-based rules, where you define how the rule interacts with the data table. We're about to get to the really interesting stuff.
Okay, we've selected our table. We know how to set up the basics of a rule. How do we actually use this data to populate attributes in our configuration?
There are two main ways to filter table rows: static entry and attribute mapping. With static entry, you're basically hard-coding a specific value. So say you only want the rule to apply to a deluxe package product option. You would enter deluxe package as a static value in the filter.
Okay, that sounds pretty straightforward. So it's saying apply this rule only if this specific value is there. What about attribute mapping?
Attribute mapping is where things get more dynamic. You link a table column to a configuration attribute. So let's say you have a table column for region and an attribute called customer region. You map them together. And the rule filters the table based on that customer region value.
So it's reacting to what's happening during the configuration, using those specific values. What happens if I'm using an array where there might be multiple values within a single attribute?
If you use array attributes in your filter, each index of the array is evaluated individually. It lets you create really precise rules. Think of it as being able to target specific items within a list based on the data in your table.
Wow, that opens up a lot of possibilities. Now that we've narrowed down the data, how does it actually get turned into actions within the configuration?
That's where the Select Attributes to Populate tab comes in. You map table columns to specific action attributes. So you select the attribute you want to change, the table column with the data, and then depending on if it's a recommendation or a constraint rule, you'll have some specific options.
Okay, could you explain a little more about the options we have with recommendation and constraint rules?
Sure. Let's start with recommendation rules. You have three options for how the data is applied: none, set, and forced set. None means the attribute is populated with data, but it isn't actively recommended. Set is a recommendation that the user can change. And forced set automatically applies the value and the user can't change it.
So with recommendations, you can have a gentle suggestion, a stronger recommendation, or a rule that's set in stone. What about constraint rules? What are our options there?
Constraint rules are all about keeping things consistent and limiting choices. So they have two types: constrain and allow. Constrain prevents the user from selecting values that don't fit the rule. It's like a safety net to ensure accuracy. Allow only permits values that comply with the rule, like setting guardrails during that configuration process.
It sounds like you can create some pretty complex workflows with all of that. What if I need to test the rules before they go live? Is there a way to do that?
Of course. You can simulate different scenarios and see how your rule behaves in the Test Table Results tab. So you select a specific column and value, run the test, and see the output. Make sure it's accurate and reliable before going live.
That's reassuring, so we can test different inputs and see what happens. This seems like a pretty robust system. What about rules specifically for recommended items? Does that setup look different?
You're right. Recommended items have some unique aspects. While the initial steps are similar, the real difference is in the Map Item Properties tab. This is where you define how items are recommended based on your table data.
So we're not just setting attribute values, but also suggesting specific items. Tell me more about how that Map Item Properties tab works.
In this tab, you map aspects of your table data to item properties, like the specific item, quantity, comments, and price. You have the flexibility to map to a table column or define static values.
So if the customer selects option A, we could recommend item X with a quantity of 2. Could I add a comment to go with the recommendation?
Exactly. You can define comments that appear alongside the item, providing extra context, like maybe explaining why the item is recommended, or include instructions for the user. There are a couple things to keep in mind, though. You can't use HTML or date attributes as inputs, and there are special considerations for array attributes.
This all makes sense, but I have to admit it's a lot to take in. Can we break down what types of data we can actually work with? What are the supported action attributes and data types in these rules?
Oracle CPQ supports a variety of action attributes, like text, integer, float, currency, HTML, and even date. Each of these attributes has a corresponding data table column type. That ensures that the data is correctly interpreted and used.
Okay, so it can handle numbers, text, dates, and currencies. It sounds pretty comprehensive.
It is, and each data type has its nuances. Like, for example, the system automatically handles exchange rates for multi-currency applications. You don't have to worry about doing that manually.
That's a huge time saver. What about HTML? Is that something we can use in these rules?
Yes, you can use HTML in recommendation rules to add some formatting and styling to recommendations. However, it's not supported for constraint rules.
So I can make certain recommendations stand out, maybe with bolding or italics,
Mhm.
or even embed an image. It seems like it would make the information a lot more engaging.
Right. Gives you more control over how things are presented visually. You've been asking great questions about this. We've talked a lot about array attributes, but could you remind me how they work in practice?
Absolutely. I think it would be really helpful to break down how we can use array attributes in both recommendation and constraint rules. They seem like such a key part of making these configurations really dynamic and responsive.
They are, and it's important to understand how they work in both types of rules. So let's start by discussing how they function with recommendation rules.
Okay, let's dive into the world of array attributes and recommendation rules.
In recommendation rules, array attributes give you really specific control over individual elements within an array. You can target individual items within a list. So for example, let's say you have an array attribute called optional features for a product. You could use a table-based rule to recommend specific features based on that data table.
Could I, for instance,
Correct.
recommend the first, third, and fifth features based on certain conditions, instead of recommending that whole list of
Right.
optional features?
Exactly. You can also use the values within an array attribute to fetch information from that data table, which means you can create rules that adjust the recommendations based on the values in the array.
So if the second item in the optional features array was feature X, I could set a rule to recommend 3 additional features from the data table based on that.
You got it. That's the power of using array attributes in recommendation rules. It lets you create these really dynamic and responsive rules based on the specific configuration.
That's really impressive.
Okay.
So how do array attributes work in constraint rules?
In constraint rules, they enforce rules and prevent invalid configurations. They're like the guardians of data integrity, making sure that all the pieces fit together correctly.
So if you had an array attribute defining the maximum quantity allowed for each item in a bundle, you could use a constraint rule to prevent exceeding those quantities.
Yes. And just like with recommendation rules, constraint rules can evaluate each element of an array attribute individually. This means you can apply different constraints to different elements, allowing for a lot of flexibility.
I could see where that would be useful. What if I want to say, the first item must be item A, but the customer can choose any other items they want?
You could absolutely set up a rule like that. That level of granular control is what makes these rules so powerful. Are there any differences we should be aware of in how these rules handle array attributes?
That's a great question. Are there any key differences in behavior between recommendation and constraint rules when it comes to handling array attributes?
There are some subtle differences to be aware of. So with recommendation rules, if you don't specify any array attributes in the filter, the results apply to all indexes of the array in the results. And the set type you choose also impacts how those recommendations are applied.
Because you still have those none set and force set options we talked about earlier.
Yeah.
What happens if there isn't a match for a specific index?
If the rule doesn't find a match, that index value along with its set type will remain unchanged. Essentially, the rule only affects the indexes that match.
It's like a precision strike. Only the matching parts of the array are changed.
What about constraint rules? How do they behave differently?
In constraint rules, if no matches are found from the data table for a specific index, constraints aren't applied to that index. It's like saying, if we don't have a specific rule for this part, let it be.
So it's more permissive with constraints. What happens if we aren't using any array attributes in the filter that pulls the data? In that case, all indexes of the array are constrained based on the return value from the rule. It's like applying a rule to the entire array, ensuring consistency across all elements.
Seems like there's a lot going on with these rules.
There is, but don't worry, you don't have to be a coding expert to use them.
That's a relief.
Yeah.
But I'm guessing with all this flexibility, there are probably also some limitations we should know about. What should we be mindful of when using these rules?
You're right, there are some quirks. For example, it's important to understand that simple table-based rules operate on a per-index basis, so they don't interact across indexes. They're treating each element within an array independently.
So each element in an array is evaluated on its own, like it has its own little rule book.
Exactly. The document actually has a table showing how these rules behave with different conditions and filters. It's a great resource to really help understand how everything works together.
That sounds useful.
Yeah.
What else should our listeners know about when working with these rules? What did you find particularly interesting or important in your research?
There were a few important points to be aware of in the document's notes section. For instance, you can specify multiple action attributes in the Select Attributes to Populate tab, meaning one rule can impact multiple attributes.
So a single rule can trigger actions across different attributes, even if they're not all present in the configuration flow. I could see how that would make them much more flexible. What else did you want to point out?
The document emphasizes the importance of deploying all your table data before testing or using the rules. If you have undeployed changes, your results won't be accurate. It's also worth noting that during deployment, data tables used in table-based rules can be included even if they have undeployed changes.
So it's important to keep our data in sync and deploy everything correctly. Sounds like the deployment process is pretty well thought out, which is great. Are there any other key takeaways from the notes section that our listeners should know about?
A couple of things about user experience. If a rule returns multiple messages, they're displayed in a comma-separated list, which is great for transparency, but could be overwhelming if there are too many, so it's best to be selective and only include essential messages.
So be mindful of how many messages the rule is generating. Make sure each one is important. What else stood out to you?
There are limitations to keep in mind when working with array attributes. If the table column is numeric, any array attributes used in the rule must also be numeric. You can't mix and match data types.
Okay, keep everything consistent. What about displaying quantities? Are there any nuances we need to be aware of?
There are some specific points about quantity display. If the quantity is less than or equal to 0, it's displayed as QI81, and if the price is on request or less than or equal to 0, it'll be displayed as a non-number value, but not the keyword base.
So there's specific logic for how quantities are displayed. What if the price isn't defined?
If the price is not defined, it'll either be blank or display default unit price. And the keyword base is also treated as default unit price if it's in the data table.
Sounds like they have a way of handling all the different scenarios. Are there any other limitations with blank queries?
Yes, a couple. Blank queries aren't supported for numeric data types, and with array attributes, you can only use attributes from the same set. In both the filter and mapping tabs, no mixing and matching there.
Okay, good to know the boundaries. All of this is making me really appreciate the flexibility and power of table-based configuration rules. They can handle such a wide range of scenarios.
They are a really powerful tool, but they're designed to be user-friendly, so you don't need to be a coding wizard to use them effectively.
That's great news for a lot of people. Earlier you mentioned that simple table-based rules work on a per-index basis. Could you explain what that means?
I think understanding that is really important for knowing how to use them. You're right. Per index means that each element in an array attribute is treated independently. Each index is evaluated on its own against the conditions and filters in the rule.
So there's no spillover effect, where the result for one index impacts another.
Exactly. Think of it as each element in the array having its own separate set of rules to follow. This applies to both recommendation and constraint rules.
That makes sense. It seems like it would simplify the logic and make the rules easier to predict. But I imagine there are still some complexities when combining different conditions and filters.
That's where the power comes in. These rules can handle a wide variety of situations and combinations. And remember that table we talked about earlier. It outlines how the rules behave based on your chosen conditions and filters.
It sounds like a roadmap to understanding how all these possibilities work together. Can we walk through some of the scenarios outlined in that table so everyone can understand how they work in practice?
Absolutely. Let's start with the most basic scenario. A rule with the condition always true, and a filter that only uses static values.
Okay, so in this case, the rule will always fire, and the filter is looking for a fixed value. What happens in this scenario?
In this scenario, the rule will map the first row from the data table that matches those static values to the specified attribute. It's a direct mapping. The first match wins.
So it's a straightforward one-to-one mapping. What happens if we start using array attributes in the mapping?
If we add array attributes to the mapping, but keep the always true condition and static value filter, the rule will map the first matching row to each index of that array attribute. Basically, every element in the array will get the same value.
It's like duplicating that value across the entire array. What if you have both array and non-array attributes in the mapping?
Same thing happens. The rule will map that first matching row to both the array attribute and the non-array attribute.
So it's like a multi-target mapping. What happens when we change the condition? Let's say we move away from that always true condition and start using attributes in the condition instead.
Let's say we use a non-array attribute for the condition and still have those static values in our filter. The rule will now map the first row that matches both the condition and those static values to the non-array attribute.
So we are adding more specificity to the rule. What happens if we are using attributes for both the condition and the filter?
It will still map the first matching row to the attribute, but now the match must satisfy both the condition and the filter.
We're making the rules more and more precise. It's like trying to find a needle in a haystack.
That's a good analogy. Things get even more interesting when we use array attributes in the conditions. So let's say we use an array attribute as our condition and still have those static values for our filter. Now, how the rule behaves depends on whether we're using array or non-array attributes in the mapping.
Okay, so we have a couple of different paths we can go down. Let's start by mapping to a non-array attribute. What happens in that case?
In that case, every index in the array attribute will run the filter, but the recommended value will be taken from the last array index that matches both the condition and the filter.
So the rule looks through every item in the array, checks if it meets the conditions, and then uses the last one it finds. What about when we map to just array attributes?
When we map to just array attributes, every index will run the filter again, but now each index will apply the first row it finds from its own results.
So every item in the array essentially has its own set of rules based on the filter results.
That is so cool. What happens if we use both array and non-array attributes in the mapping?
It's a combination of the previous two scenarios. All indexes will run the filter, and each index will apply the first row from its filter results. But the non-array attribute will be set to the last result from the last index. That matched both the condition and the filter. We're getting into some pretty intricate combinations here.
It is a lot.
Yeah.
But once you grasp how this works, you can see how much power there is in table-based configuration rules.
I am starting to see that.
Yeah, it really is amazing how much you can do with these rules. They're powerful, but they're designed to be user-friendly too.
Right. We've been talking about them for a while. And I haven't seen any complicated code. It's all point and click, making it much easier for people who might not be coding experts.
That's exactly what Oracle CPQ has done so well. They've taken something complex and made it accessible. The interface is designed to be intuitive and easy to use.
Sounds like they've thought of everything. Are there any other tips or best practices for working with table-based configuration rules? What are some common pitfalls to avoid?
There are definitely some things to keep in mind. One common mistake is forgetting to deploy all the necessary data before testing or using your rules. We touched on this earlier, but it's worth repeating.
It's like trying to follow a recipe without all the ingredients. You might end up with something completely different than what you expected.
Exactly. Always double check that your data is deployed and up to date before working with the rules.
Noted. Are there any other potential pitfalls?
Another thing to be careful with is using blank values in queries. We talked about how certain operators behave differently with blank values, so it's important to be mindful of this in general. Blank values can sometimes lead to unexpected results.
So it's best to be really deliberate when using blank values. Don't assume the system will interpret them the way you expect it to.
Exactly. And along those same lines, be aware of data type limitations, especially when working with array attributes. If your table column is numeric, make sure any array attributes in the rule are also numeric. Don't mix and match data types.
Got it. Keep everything consistent. What other tips do you have?
Remember that multiple messages returned by a rule will be displayed to the user as a comma-separated list. This is great for transparency, but it can be overwhelming if there are too many messages.
Information overload. Too much of a good thing can be a bad thing. How do we avoid overwhelming the user with too much information?
Be selective about the messages you include. Each one should be essential and provide valuable information. Don't clutter the interface with unnecessary messages.
Keep the messaging clear and concise. Got it. What about testing the rules?
Always test your rules thoroughly before they go live. The Test Table Results tab is your best friend. Use it to try different scenarios and make sure everything is working as expected.
Testing is so important. It's like a dress rehearsal before the big performance. Any other words of wisdom?
Don't be afraid to experiment. Play around with different conditions, filters, and mappings to see what you can achieve. The more you explore, the more you'll understand the nuances of these rules.
I love that. Embrace the experimentation. It's how we learn and discover new things.
Absolutely. And remember, the documentation is a valuable resource if you need help.
We've covered a lot of ground today, but I think it's time to step back and think about the bigger picture. Why are these rules so important? Why should our listeners care?
Well, Table-based configuration rules represent a significant step forward in how we manage complex products configurations. They give businesses the power to make things more dynamic and user-friendly.
So it's not just about being more efficient on the technical side. It's also about improving the experience for the user.
Exactly. Businesses can streamline their sales process, reduce errors, and create a better experience for their customers.
It sounds like you're taking the guesswork out of the process and replacing it with intelligent guidance.
You got it. As businesses deal with increasingly complex products and demanding customers, managing those configurations well is more important than ever.
So these rules aren't just a nice bonus. They're becoming essential for staying competitive.
That's right. They're a must-have for any business that deals with complex configurations.
This has been a fascinating deep dive, and it feels like we've only scratched the surface of what's possible.
I agree, there's so much more to explore, but I think we've provided a good foundation. Now it's time to see table-based configuration rules in action.
Let's do it.
Yeah.
Earlier, we talked about using array attributes to pull information from data tables. It's a really interesting concept. But could we walk through a real-world example to see how it works in practice?
Of course. A practical example is a great way to make this more concrete. Let's imagine a company that sells customizable software packages. Each package has a core set of features, but customers can choose from a menu of optional add-ons.
Okay, so we have our core software package and a list of optional features. How would we use array attributes and table-based configuration rules to manage this?
We could create an array attribute called selected add-ons to keep track of what the customer chooses. Each element in the array represents a specific add-on.
So if the customer picks 3 add-ons, there are 3 elements in the array.
That's right. Now, let's say we also have a data table with information about each add-on, like compatibility, potential conflicts, and recommendations for related add-ons.
So we've got a database of add-on information. How do we connect that to the selected add-ons array and our table-based rules?
This is where things get really exciting. We can create a table-based recommendation rule that uses the selected add-ons array as a filter. The rule would check the data table for each add-on that the customer selects.
It's dynamically checking the database based on the customer's choices. That's amazing. What happens next?
The rule can do several things based on the data it finds. It can alert the user to compatibility issues or potential conflicts. It can also dynamically recommend additional add-ons that complement the customer's selections.
So it's not just about preventing errors, it's also about suggesting a more complete solution.
Exactly, and all of this is happening behind the scenes. The customer doesn't even have to know about the complex logic that's running.
It's like having a built-in expert advisor.
Yeah.
This is a great example of how powerful table-based configuration rules can be.
This is just one example. There are so many possibilities when you combine array attributes with table-based rules and external data.
It feels like we're just scratching the surface of what's possible.
I agree. This is a game changer for businesses. They can move away from static rule-based systems and create more dynamic and personalized experiences for their customers.
This has been an incredibly informative deep dive. It's clear that table-based configuration rules offer a really effective way to manage complexity and create intelligent configurations.
I couldn't agree more, and this is just the beginning. As technology continues to evolve, I can only imagine the even more innovative ways that these rules will be used to shape the future of configuration.
I'm excited to see what the future holds. But for now, I think it's time to wrap up this part of our deep dive. We've covered a lot, and I'm sure our listeners are ready to take a break and process everything.
Yes, it's a lot to take in, but I think we've given our listeners a solid understanding of table-based configuration rules and how they can be used to create amazing configuration experiences.
I couldn't have said it better myself. We've explored the mechanics, the power, and even saw a real-world example of these rules in action. But before we wrap up entirely, I'd like to leave our listeners with something to think about.
I love that. It's all about extending the learning beyond the episode.
Exactly. For our listeners who are ready to take their Oracle CPQ skills to the next level, here's a question to consider. How could you leverage the power of array attributes and index-specific operations to create even more sophisticated and dynamic configuration rules in your own Oracle CPQ environment?
That's a great question. It challenges our listeners to think beyond the basics and start envisioning how they can push the boundaries of what's possible.
We've seen how these rules can interact with data tables, make recommendations, enforce constraints, and work with individual elements within arrays. What other creative applications are out there? What kind of innovative solutions could you come up with? That's what I want you to think about.
Yeah, it's exciting to think about all the possibilities.
It is. We've explored the ins and outs of table-based configuration rules, from setting them up to understanding how they work behind the scenes, and we even saw them in action.
We've covered a lot of ground, but it's all about empowering our listeners to take this knowledge and apply it to their own work.
Exactly. We want our listeners to feel confident and excited to unlock the potential of these rules. But before we say goodbye, I think it would be helpful to revisit that table we've mentioned a few times, the one that outlines how the rules behave under different conditions and filters.
That's a good idea. It can be a really useful reference for understanding how the different pieces fit together.
Let's take a look at a few more scenarios from the table. We've already seen what happens when we use the always true condition. So let's look at what happens when we have an array attribute in the condition and static values in the filter.
This is where things start to get really dynamic. Remember, in this scenario, every index of the array attribute will run the filter. But how the results are applied depends on what types of attributes we're using in the mapping.
Right. We have a few different possibilities here. Let's start with the case where we're mapping to non-array attributes. What happens then?
In this case, the rule will check every index of the array attribute against the static values in the filter. The recommended value will then be taken from the last index that matches both the condition and the filter.
So it's like going through a checklist, checking each item in the array against the rule, and then taking the last one that fits.
Exactly. Now, what happens if we switch gears and map to only array attributes?
Okay, so we're changing the target of the mapping. What's the outcome now?
Now things get really interesting. The rule still checks each index of the array attribute against the filter, but now each index will get its own personalized mapping based on its own results.
It's like each element in the array gets its own mini rule, tailored just for it.
I like that analogy. It highlights how dynamic these rules can be.
What about the case where we're mapping to both array and non-array attributes?
That scenario is like combining the best of both worlds. Each index of the array attribute gets its own personalized mapping, just like in the previous scenario. But the non-array attribute is set to the last result from the last index that matched the condition and filter.
So we're seeing a mix of personalized mapping for the array elements and a specific mapping for the non-array attribute.
Exactly. It demonstrates the flexibility and power of these rules to handle these complex scenarios.
This table is such a valuable resource for anyone working with table-based configuration rules. It lays out the logic in a really clear and concise way.
I agree. It's a great tool for understanding how these rules work and for troubleshooting any issues that might arise.
We've explored so much in this deep dive, from the basic setup of these rules to their incredibly nuanced applications.
We've seen how they can enhance efficiency, reduce errors, and ultimately create a more satisfying experience for everyone involved.
It's been a fascinating journey, and I hope our listeners are feeling inspired to unlock the full potential of table-based configuration rules in their own work.
I'm sure they are. Remember, these rules are all about giving you more control, more flexibility, and more power to create truly intelligent configurations.
And for our listeners who are eager to learn more, don't forget to check out the documentation. It's a wealth of information and can help you dive even deeper into this topic.
It's been a pleasure exploring this with you, and I'm excited to see what our listeners create with this newfound knowledge.
Thanks for joining us on this deep dive into Oracle CPQ. We hope you enjoyed the episode and feel empowered to take your configuration skills to the next level. Until next time, keep learning, keep exploring, and keep pushing the boundaries of what's possible